Hello everyone, GameData1010 here, and I'm here with the next installment of Minecraft in a Calculator series. So this episode today, we have generating meshes. Now meshes are a core aspect of video games, where you're able to build 3D objects using a list of vertices and a list of indices. Now I got these two variables set up right here, but before I even get into the meshes, I want to have some updates from the last video. So somebody on the r/Desmos community let me know that there's actually a width and height variable in built into Desmos. So you don't have to go ahead and search your aspect ratio. You can just put in width and height and you're all set. Next is this projection equation. You don't actually need the third component as far as my knowledge goes because it's not used in here and it works perfectly fine. So now let's get into making meshes in our 3D renderer. So first up we need to figure out what we want to make. So I suggest we make the simple cube. So where do we go from there? Well, we can actually do something real quick to help us understand what we're doing, and that is by generating the points on the cube first. Alright, so I made this little array right here of points to just help us generate these points of the cube. In each cardinal direction, it does minus 1, 1, minus 1, 1, minus 1, 1. So then we generate this cube. So now we have an idea of what we're working with. Next, I wanted to generate another array to label these. And to label them, you just do this. And we have an array set. Alright, I've written out all the points, and it's just simple. I did it like if it was binary counting. So negative 1, negative 1, negative 1, negative 1, negative 1, 1, and then it continues all the way until it's 1, 1, 1. Quite simple, and we just make sure that we have the proper amount of points by dividing by 3. We get 8, 8 right there. We understand how the vertices and indices work. It's now important to get over to rendering it so that we can actually figure out what if we're rendering it properly. So it's going to be 3 new functions in this here. So we're going to have 2 triangle functions and 1 point function. And I'm going to get started with the point function. Now the point function takes in a number, the vertex array, and the position. So, and what we do with this is we go ahead and search in the vertex array the three coordinates that we need for this point. And in order to do that, we do 3n plus 1, and then this is going to be a series, 3n plus 2 and 3n plus 3. That way when we put in 0, it will get 1, 2, 3, 1, we'll get 4, 5, 6, 3, we'll get 7, 8, 9, and so on. Next we have to make sure we subtract the camera position and then add the position that it's at. That way we're subtracting our position so that we can get the proper view, but we add the position of this object itself so that we can move it around independently of the camera. Next function that we need, we're going to need the capital TRI function, and that takes in a number, the index array, the vertex array, and then the position. And simply enough, we just join those 3 points. And it's as simple as that. So you do point, and we have to grab the specific point that we want from the index array, because that way we know which way to connect it. So we want to connect up, say, index 1 to 2 to 3, and then we'll have our triangle. So we do point at index 3n plus 1. We find the point at the specific index, and then we shove in the vertex array and then our position. And then that's how we find the point at our specific index. And then all you do is this quite the same like the point function, and we just change this to +2 and then +3. And now we are almost done, and we have the lowercase tri function, which takes in a single triangle and renders it. To do that, we do polygon, and then we draw our triangle with each point, so 1, 2, and 3. And then since this triangle that we generate should have a set of 9 points, we just do this again with 4, 5, 6, and 7, 8, 9. And there we have it. We have our function to generate triangles. But now we have to generate each triangle for our indices. And the last way to do that is we create an array that has all these polygons in it. So we take that and we plug in our triangle, and then we do that for each triangle in our array. So we're going to have our iterator, I don't know what it's called, as n, and then our index buffer and 1, and then our vertex, and then our position. Nope. And then we do for n is equal to 0, because these functions start at 0, all the way up to 11, because there are 6 faces on a cube, and each face needs to be split up into 2 triangles. Now we can get on to our index array and figure out how we need to connect it. So let's go from 0 to 4 to 2. So we go, and it's as simple as 0 to 4 to 2. Now it looks like we messed up the array, which is a simple fix. X, Y, Z, I think. Yep, there we go. Alright. So let's go from 0 to 1 to 2 instead. And then boom, we have our triangle right there, and then we just have to do it for each triangle. Alright, and then plugging in all of our indices, we have our cube right here. And right now it's transparent, but it's an easy fix by just taking this and putting the fill to 1. And there we go, now we have our non-transparent cube. And that is it for our meshes tutorial. In the next tutorial, I'll be going over rendering techniques, because when you have a bunch of these faces, it gets very slow very fast. So that will be the next tutorial, and I'm sorry that this video came out so late. It's because I was on a camping trip, and it was also because I had a lot of school to catch up on because of said camping trip. Next tutorial should be out soon, and I'll see you all later.